Let's look at the next two approximate implementation of LRU, 1-bit and 2-bit clock algorithms. The name clock algorithm comes from the idea that we keep the page numbers in a circular list, and there is a clock hand that will go around to find a page whose reference bit is 0. And again, both algorithms require cooperation between hardware and software. As always, the memory hardware will set the reference bit to 1 every time a page is referenced. And then the software will search a particular page, will search a victim page by moving the pointer around. And every time, whenever the algorithm finds a page with reference bit 1, it will reset that reference bit to 0. So here we start at 7 and the reference bit of that page is 1. So the algorithm will reset the reference bit to 0 and continue searching. So now if we'll search to the next page, and we do find a page with reference bit 0, so 1 becomes the victim. So what happened when all the reference bit of our pages are all 1? So in which case, when the algorithm is looking for a reference bit 0, it will reset the reference bit to 0 for all of them. Continue to this page and then reset the reference bit to 0, and you will keep going continue to the next page, reset to 0, continue to the next page, reset to 0, continue to the next page, reset to 0, continue the next page, reset to 0, and finally the clock hand is back. Finally the clock hand is back to that page. That page becomes the victim after the algorithm check all the pages. So this is why sometimes this algorithm is also known as the second chance, because we are giving all the pages a second chance to stay in the RAM until the algorithm makes a full circle to find the victim page. So the next algorithm, 2-bit clock, is an improvement to 1-bit clock algorithm. To understand what it's trying to improve, let's look at the case when the page fault handler is about to bring in a page from the swap disk. On the left side of the screen, you see a victim page which was not modified. That means the page fault handler can just replace that page with a new page from the swap disk. But on the right hand side, we see a victim page that was modified, whose content has been modified by the owner. In that case, the page fault handler cannot just overwrite this page. Before a new page can be brought in from the swap disk, this page must first be written to the swap disk, and then the page fault handler can bring in a new page to replace that victim page. So the 2-bit algorithm is basically trying to search this type of victim first before it search for this type of victim. So this is why we call this algorithm a 2-bit clock algorithm, because in addition to using the reference bit, the algorithm also look at the modified bit of each page. So we're gonna call the reference bit the R bit, and the modified bit is the M bit. And based on the combination of the 2 bits, we can see 4 different classes of page. So the first class, we call it class 0, when both the reference bit and the modified bits are 0, 0, 0. That means this page was not referenced and was not modified. And the second class is class 1, when the reference bit is 0 and the modified bit is 1. And then the third class is when the reference bit is 1 the modified bit is 0, and then the last page, class 3, is when both bits are 1. So again, always the algorithm is trying to look for a victim from this class first. If it cannot find any victim of this category, then it will try to search a victim page of this type. But similar to the 1-bit clock algorithm, whenever the algorithm is searching for a victim page and it sees the reference bit is 1 on a particular page, then the algorithm will reset the reference bit to 0. So what is the effect of resetting the R bit to 0? So pages of type 2 will become page of type 0, and pages of type 3 will become page of type 1. So the 2-bit clock algorithm is essentially a multi-pass algorithm. During the first pass, it will look for class 0, which are pages not used, not modified. But at the same time, while searching for class 0, it will change reference bit which is not 0 to 0, effectively turning page of type 2 to type 0 and pages of type 3 to type 1. If after the first pass it couldn't find page of class 0, it will continue to repeat again to search for class 0, but this time hopefully pages of class 2 have turned into page of type 0, so then the second pass will successfully find a victim page. But still, if after the second pass it couldn't find a victim, it will continue to search again, but this time it will search for class 1, either original class 1 or class 1 that come from type 3. So overall effect of this multipass search is that modified pages have lower priority to be selected as a victim page. So let's use this example to see how the 2-bit clock algorithm works. So the leftmost bit is the reference bit and the second bit is the modified bit. So we start from page 5, and in the first pass we always look for class 0, which is R0 and M0. So page 5 is not class 0, but at the same time the algorithm will reset the R bit from 1 to 0. So page 5 is not a victim, but we are going to reset that bit to 0 and continue searching to the next entry, which is that page. And again, that page is not 0, 0. We reset the R bit to 0, and you keep going to the next entry. Fortunately, at this point, we find a type 0, 0, and that page becomes the victim. So what if all the reference bits are 1? So we start at page 5 again. We reset the reference bit from 1 to 0 and continue searching to the next entry. And again, we reset the reference bit to 0 and continue searching. So reset that reference bit to 0, continue searching, reset that reference bit to 0, continue searching, reset, continue searching, reset and continue searching until finally we find page 5 as our victim.